All right, hello, my name is Eoin. I work for Microsoft on Havoc Physics, and we've been working on an extension to allow you to describe physical objects in glTF. So what do we mean by physics? So particularly we're concerned with rigid body dynamics. So objects that don't change shape. The reason for this is the existing solutions out there for rigid bodies are pretty mature. They might be slightly different in behavior and the amount of dials and settings they might expose, but the fundamental concepts are all very, very similar. And that's what we've really focused on describing in the extension. Why you might want to use physics, it'll make scenes much more believable, you can make them more interesting, more interactive, and you save your animators a whole ton of time having to author something like this. So what's in the physics extension? So let's draw some diagrams as to what's in the extension. So you have your nodes, and we've extended the glTF spec with a few shapes. So in physics, you want additional collision shapes that might not necessarily match your render geometry. You might also want them to be curved surfaces. So we've got some spheres, capsules, boxes, that sort of thing. That saves you a lot of meshes, or memory, and you don't have to collide whole triangulated meshes. So the nodes can reference a shape and say, this is the collision geometry I want to use for my node. In addition, we have some physics materials. So we've augmented the document with an extra kind of material that describes friction and restitution, what you might want, how an object might slide on another object, or how it might bounce. And those are referenced by the nodes as well. And with that, you can get a kind of physical behavior. We've also got joints, and this is a little abstract, but we'll get into a little more visual representation of it. So a joint is how you connect two objects together. You can think of a door handle or a drawer or a cupboard that opens up. So a node can reference a joint definition, and there's a very generic description of what a joint is. And it also references another node that you're attached to. So little abstract, so let's go through what that might look like. So here, you've got a scene, you've got some doors in it. Let's break that apart. You've got two doors, or you've got two, oops, excuse me, how do I play the video? So you've got two objects, they're distinct, and you put a node on each of them to say where the pivots, what the connected points are. And then you can define limits and say, these are the places where that joint is not violated. So that's the pink area here. And that allows you to say, that allows the physics simulation to say, this is how those objects should behave, how they should be connected, and it can apply forces to keep them in that sort of consistent for the physics representation. So when you tie all of this together, you get something like this. And this is maybe not something that a normal person would do in a normal scene, but it's quite fun. So this uses a lot of the properties. There's a lot of constrained objects in here. There's a lot of objects with different behaviors. That wrecking ball is a long, complicated chain. Wouldn't recommend this, but it does work in your web browser. I'm sure there's a lovely video. Everyone wants to see it again. But so call to action. There's a few more things in physics that I haven't gone into. There's collision filters and triggers. Those are a little bit more abstract, and they don't make for very interesting videos, so I left them out. But at this QR code, that's the link to the pull request, where we have all the details on what's in the schema. There's some implementations. There's some sample assets. And this is my email address here if you want to reach out. I'd love to hear about any implementations or people using this. And that's all I've got for physics. Next up, we've got audio.